And we are on the air. Hello, everyone. Today is Friday, January 27th, and this is episode 25 of Get Your Tech On, the cable industry's #1 DOCSIS podcast. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us is the man who is world famous in certain parts of the country, John Downey, CMTS technical leader at Cisco Systems. Welcome, John. Thanks for coming back.
How come we're world famous, but only in one country?
Oh, certain parts of the country.
Only parts of the country.
Well, we won't say what parts. So today's episode is a good one. We've accumulated a backlog of questions on CMTS utilization. We'll be covering those and likely, as usual, go off on a number of tangents. So let's start off with our first question, which comes in from Heather. Heather writes, here's my situation. As you know, she has I believe this is a 10K with MC 20x20 cards in them. She has 20 upstream ports. She says, as you know, there are 20 upstream ports on each card and 2 jumpers that plug into those upstream ports. The upstream ports are grouped in 5, so each jumper has 10 upstream carriers, upstream 0 through 9 on jumper 1, and upstream 10 through 19 on jumper 2. My first node is using upstream 0 through upstream 3 and downstream 0. The second node is using upstream 4 through upstream 7 and downstream 1. And modems are locking on all 4 carriers. My third node on card 7/0 is using the last 2 cables from jumper 1, upstreams 8 and upstream 9, and the first 2 cables from jumper 2, upstream 10 and upstream 11, and using downstream 2. But modems are only locking on the first 2 downstream carriers and not seeing the other 2 on the third node. Any idea why? So this is a long question.
Upstream carrier. Yeah. So let's clarify a couple things. And by the way, your audio went out a couple of times. I don't think it's that bad though. Instead of saying jumpers, because as an RF guy, a jumper is a cable. I think she means bundles of 10. We ship our cables in a kit, and it's bundles of 10, and they're red, white, blue, green, yellow, purple, orange, black, gray, brown. So there's a color code to it. Now, so let's call it bundles instead of jumpers, right? So that bundle of 10, we also call a MAC domain a downstream and its associated upstreams. So downstream 0 has 4 upstreams by default. They can be reassigned any way you want, but by default, downstream 0 would go with the first 4 upstreams, upstream 0, 1, 2, 3, just like she said. Now, the third MAC domain is an oddball because 4 of its upstream cables, 2 are in the first bundle of 10, and the other 2 are in the second bundle of 10. Now, what I've seen people do by mistake is they don't really follow their color code, and when you take these 2 black bundles of 10 and go and route them through your rack to the other side, sometimes you mislabel or you crisscross cables and you actually have the wrong MAC domain or the wrong cable. Red is not red like it should be. Like red from one bundle is not red from the other bundle, or vice versa. There are some commands you could run to prove that maybe the configuration's not wrong. Like one command is show cable URM, which stands for upstream receiver mapping. Show run of the interface, show controller of the interface. So I've seen where customers will copy and paste to a text editor their running configuration of one MAC domain, a cable interface, and copy it into another cable interface, and that overwrites the connector commands. The connector command is assigned. So you can assign any upstream connector to a downstream within a line card. And it could be that maybe they just misconfigured or copy pasted wrong. Sometimes it causes issues when you copy and paste. So hopefully it's either bad cabling, cable miswired, configuration was mismatched, or any of the above.
Sure. The other thing that I've also seen is when you actually have bad connectors on the cable itself. So you have that little test connector that has an MCX to F connector that gives you the ability to actually go in and verify that the connectors are in good shape.
Yeah, it's a good point, because on our header that goes into the 10K, the 20x20 card, is a 1x10, meaning it's called a UCH, upstream cable holder 2, UCH2. And there's a clip that slides up and down. So there's a T10 Torx to tighten it up. I've seen where people put the cables in, they don't hold it all the way in, and they push the clip down and tighten it up. But if they aren't all the way in, when you put the header onto the line card, it won't seat all the way. But I've seen it more, it could have been the first two, but I've seen it more in the middle two cables where the middle screw goes through, because some people just can't hold the cables in, and where they didn't tighten the clip up all the way. And once they push the UCH into the line card actually pushes the cables back through the back of the header. So yeah, it could be just bad cabling, and maybe the cable's not bad, but it wasn't seated properly.
Right. Okay.
These ways, take the header off, look at it, pull the shroud down, and see if all the cables look about the same level.
Yep, absolutely. All right, let's get on to the next question. This is a three-parter, and I think we have a backup slide to give some information on it. So this says, comes in from Jesse. He says, I have another question that comes in. It comes in three parts. He's telling us this. Can you break down the flap list, how to best use it? What is the recommended best value for cable modem max CPE? And finally, is voice over IP always guaranteed to flow on one downstream channel, or is there a chance that it could get striped across multiple bonded downstreams, causing jitter, latency, and maybe even packet loss? Thanks for your help.
Yeah, so you and I have talked about this, so we put this slide together to cover some of these things. If you can you pop the slide up?
Yeah,
slides? I don't know if you can pop it up. All right, very good. So to kind of go through these, and I have no problem, you putting this on the website, or people can download it, or make a PDF out of it, whatever you want to do, or they can just download the podcast and watch it as we're talking. This is some best practices we started putting together years ago, and we keep updating it, and now we have a CBR8, so we have updated best practices for CBR8. You and I have talked about maybe submitting this for SCTE Expo in Denver next September, is it? Or October?
Yeah, I think it's in September. I'm not sure. Hopefully it's in September, not October, because you get more snowstorms in October.
Last time we had it in October. That one year we had a foot of snow. So hopefully you and I will be able to do a in tandem presentation for SCTE Expo, because I think it usually comes off pretty good. So let's cover this topic of the flap list, the max CPE, and the voice traffic for 3.0 eMTA. As far as the flap list goes, this is a feature that Cisco's had forever, and I think everyone likes it in the industry so much that it became part of the DOCSIS 3.0 spec. It never really was part of the spec. It was a Cisco-centric type of feature, and now it's called, I think, modem diagnostic log. Is that right? That sound right? MDL, modem diagnostic.
Yeah, I mean, I still think it's the industry, just everyone refers to it as flap list.
And it's funny because you think of flap list, you think of modem flapping, meaning going online, offline, and that's not it at all. What we did is since we're doing station maintenance 15 to 20 seconds, that station maintenance is always there regardless if there's any traffic at all. So why don't we look at the station maintenance burst every 15, 20 seconds and get a general idea of what the modems are doing. Are they doing power adjustments? Are they doing timing adjustments? Are they frequency upstream frequency adjustments? So we can look at that station maintenance and make some logs and history of what those modems are doing. I mean, it's not generating any more CPU because it's always happening anyway. So what we did is we put this into logical buckets, and we said, all right, modems that have power adjustments, we'll track it. Now, if it has 3 or 4 power adjustments in a row, then we'll put it in the flap list. So we can have power adjustments, but it might not make the flap list because it didn't hit the threshold that we configured for power adjustments. Even for instance, for the power adjustment, if I see a modem change more than 3 dB on the upstream, transmit more than 3 dB difference, the next station maintenance, well, obviously there's something wrong. The customer changed out a splitter real fast. I don't know how fast he did it. Or there's a loose connector on a tap or the ground block, making the levels jump up and down. Now, when you look at day to night, levels can change, 3, 4 dB from winter to summer, day to night, whatever. But that's not a 15-second window. You're talking 6 months. So you're going to see upstream levels change, but if they change that drastically in such a short window, then we put it in the flap list. So we can track modems that have power adjustments. Modems that are flapping, insertions means they're going not just online, offline, but they're actually going maybe a NID-R1, a NID-R2, a NID-RC, a NID-D offline. So we can track modems that don't even register, but they seem to just keep cycling through the registration process. So ways I've used this lately is when I look at another feature on the flap list, it's called misses. A miss would be the equivalent of a T3 timeout in a modem's log itself. If you queried the modem, you can see T3 and T4 timeouts. T3 timeouts usually upstream related, T4 usually downstream related. Now, I can have misses in the flap list, and it's perfectly normal because when I'm doing station maintenance to the modem, it might say, hey, my levels look good, but maybe that upstream is noisy, so it didn't actually come back to the CMTS, and CMTS, like, I didn't get a response, give me another, how did you say your levels were? So this can happen, this round trip, and it goes into this fast polling mode. So I could have a miss, a T3 timeout in the modem, a miss in the flap list, and then the next time it goes around, it goes through, and then I record a hit. So a hit is a successful three-way handshake for station maintenance. Now, there are some, I always call it chicken little, the sky is falling. If you make your thresholds too aggressive, you could have so much flapping that you kind of disregard everything because it's just too much to handle. Now, if you make your thresholds realistic, you can use the flap list for troubleshooting and even sending out your techs for daily work orders. I've had customers clear the flap list, let it build up over 24 hours, bubble it, sort it up so that the worst modems at the top, and then send the techs out to work on the worst operating modems, whether it's power level issues or modems that seem to be online and offline. The one thing I point out though with the flap list, because it's tracking station maintenance, the mod profile you use can be very a false indicator. Meaning, if I'm using QPSK for the station maintenance of a modem, but 64 QAM for the data of the modem, that QPSK is so robust, the flap list never actually accumulates anything. So you think everything's hunky-dory, nothing wrong, but then you're actually dropping all your voice packets, you're dropping all your data packets, but the station maintenance is working fine and modem's online. You can do a ping DOCSIS and it works fine, but then you do a ping and the ping doesn't work because ping DOCSIS would use station maintenance burst and ping would use an A long or A short burst. So for that reason alone, I tell people, don't make your flap list too lenient. I make my mod profile 16 QAM for the maintenance of the modem, so the flap list is actually as vulnerable or close to as vulnerable to noise problems as the data would be at 64 QAM. Now, you might come back and say, well, why don't we do 64 QAM for the station maintenance to match up with the data? Like, well, if you talk to the Broadcom and Intel and the people that make the upstream chips, they don't want anything higher than 16 QAM for the maintenance of the modem because it comes through so fast, you wouldn't get good readings for MER, you wouldn't get good readings for pre-equalization, you wouldn't get good readings for levels. So we make it a little bit slower modulation so we get a little bit longer in time to get a good reading. So that's a quick run. I say quick rundown of flap list, but that was kind of long-winded. When we look at the modem XCPE, it's a global command, and the reason I point this out is I've had customers use cable modem XCP Unlimited. Now, when you do that, if I'm a hacker, I could take my cable modem and a PC behind it, and that PC is going to get, an IP address associated with the cable modem because the PC is considered the CPE of the modem. Modem is the host. What could happen is I could keep changing the MAC address on my PC and keep re-registering and use up a bunch of IP space from your DHCP server. It's almost like a denial of service attack on your DHCP server. I still only have one MAC address, one PC behind my modem, but if I keep changing it, the CMTS is still holding on to that table, that CAM table, that MAC address and IP address association. And that could be for 4 hours, it could be for 24 hours. So you could have one PC trying to eat up all your IP space. So I tell people, don't make it max CPE unlimited, make it 10. But if you have multiple, what do you call it, a multi-line EMTA that might have 12 voice lines, maybe you should make it max CPE 13 or 14. That way the 12 voice lines work and a PC or two PCs behind it also, it could be a router, whatever, also gets an IP address.
Now, can't you
That's
just
for modem max CPE.
Can't you limit the CPEs in the
Sam?
.config file?
Yeah, so normally in the modem CM file, you might say 1 or 2, but that is not the same as what is being held in history in the CMTS. Do you understand? The cable modem might say, all right, you can allow 1 PC behind me, but what if that PC just keeps changing the MAC address? It's still only 1. Do you understand?
Sure. So actually, what you're
Because
doing,
the cable modem doesn't keep.
yeah, the cable
The cable modem doesn't have a history.
different changing IPs.
It's the cable modem is looking at how many PCs simultaneously, but the CMTS is keeping a history of all the PCs within the last, say, 4 to 24 hours.
Right.
So I could have 1 PC behind the cable modem, so the cable modem's happy, but then online, offline, I shut the modem off, I reboot it, comes up with a different MAC address, but now the CMTS says, oh, now 2 PCs behind the modem. Only 1 is active, but I'm still holding on to your old MAC address.
Yep, absolutely.
And it's still holding on to the IP space. All right, so that's one of the things I bring up. The other one was you asked about, voice traffic from a DOCSIS 3.0 eMTA. By default, many people probably don't know this. By default, that voice traffic is bonded because downstream is using a low latency best effort flow. It's a best effort flow, but it's a low latency queue. So it's usually higher priority, less latency, less jitter, and all that. But if I am bonding that voice traffic and do all the math for voice calls, 64 kilobit per second, 20, a G711 codec, 20 millisecond packetization, do all the math, DPI plus, it's about 229 bytes. I do all the math for overhead. It ends up being about 110, 115 kilobits per second. That's not very fast flow. But if you took that flow and spread it across 8 downstreams, you'd only be putting about 12.5 kilobit per second on each downstream. It's like, that almost seems counterintuitive. It's like, why would I be spreading such a low speed flow and then have to resequence everything back at the cable modem?
So you're saying
now most cable modems
this is how
perfectly fine.
that voice is bonded by default. It's spread
by
across
default.
all downstreams.
Yeah, at least on the Cisco CMTS, by default, we're actually bonding it. So we came out after I went from 4-channel downstream to 8-channel downstream and started seeing voice quality issues. We came out with a global command to say, you know what? Let's take any voice flows and put them down the primary downstream. That way they're not bonded. That way they're put down a single downstream. And that's the command I'm showing right there. So if you put that command in exactly as you see it, then the voice traffic should not be bonded at all. It'll be sent down the primary downstream.
Okay.
Figure out the primary downstream, we could only do.
Yeah. So for people that are just listening on the podcast, the command is this goes in the, is this a global command or this command goes in the interface, which is the command is cable DOCSIS 3.0 voice.
It's a global command on the CMTS. Yeah, global command on the CMTS.
Okay.
So it's cable DOCSIS 3.0 voice downstream, acquired attribute mask 0, forbidden attribute mask 80 million. So if you're on the podcast, I'd probably recommend you download the slides.
Yep, absolutely.
So that people can see the actual commands. So and I had a note at the bottom there that all voice traffic is never bonded. So even if you're doing upstream 4-channel upstream bonding, upstream voice traffic is sent up a individual upstream, so we can put it in a scheduler for that upstream channel, and we can guarantee less than 2 millisecond jitter. So we have an upstream scheduling wheel that limits to less than 2 milliseconds of jitter.
Okay, because that's
so
what
you
I
shouldn't
thought.
have to worry about upstream.
That upstream traffic or voice traffic, I did not think was automatically bonded in the upstream, but I also thought it was not automatically bonded in the downstream. So I am glad that you pointed out that command. That's a pretty important command to have if you're not already doing that in the downstream.
Yeah, I mean, could you imagine if you went to 24 downstream and trying to do voice? 115 kilobit per second flow across 24 downstreams. I'm like, that doesn't sound very intuitive, or it doesn't sound like it makes sense. It'd almost be better. I mean, this command makes it easy to just put that low speed flow on a single downstream. I've taken this a step further, and I haven't really pursued it that far. I said, what about other flows that are latency and jitter sensitive, like gaming? If my son is playing a PlayStation and it only needs 4 or 5 megabits per second, does it behoove me to take that specific service flow and push it on a 4-channel bonding group instead of a 24-channel bonding group? Maybe.
Yeah, that's
So I haven't seen that problem come up,
you can do that
but
with
I'm just. So it would take a lot more work. So, but there, I mean, that's why we have DOCSIS 1.1, quality of service and service flows and steering of servos. So it would take a lot more than us talking here to go through that.
So, all right. Well, let's move on here. Bill writes, "Hi guys, keep up the great podcast. Can you help me out? I'm struggling to get my DOCSIS 3 load balancing working properly. Can you go over the differences in all of the DOCSIS 3 load balancing commands? Also, it'd be great if you could go over what you'd recommend in a load balancing profile." So we put together some slides on this, which I'll pop up here, and we can dig into these as I'm getting these up.
Yeah, load balance is always a good topic. We're trying to get the most efficiency out of our downstream frequencies and trying to balance as best we can. And to preface that whole thing, I tell people, take a step back and say, all right, are we really concerned about the load on all interfaces being perfect? And in my eyes, not really. In my eyes, the idea and the goal here is to make sure no interfaces are congested and that everyone is getting the speed that they're trying to get. The third point and goal of that is do it with the least amount of moves possible, because the more movement that you have of modems, the more probability of modems breaking up, going offline, not supporting DCC, not supporting DBC, and then having layer 3 hang problems. And then you have to power cycle the modem or whatever. So to do true load balancing, we should balance the load, not just modem count. We should balance utilization. We came up with some commands to now support DOCSIS 3.0 load balance between bonding groups. Now, originally, we didn't allow utilization load balance for 3.0 across bonding groups that were overlapping like that. The bonding groups had to be non-overlapping because we were looking at each RF channel individually. Now in the CBR8, we take a bonding group and treat it as a virtual channel, so even if it's overlapping, it doesn't matter. So now we do support overlapping bonding groups. And when I say overlapping bonding groups, that's not the same as saying embedded bonding groups. You could have 2 4-channel bonding groups embedded in an 8-channel bonding group, and that's fine. We only load balance between like bonding groups. So a 4-channel modem will look for another 4-channel bonding group to load balance between the multiple 4s. 8 channels between the multiple 8s. So we now support utilization load balance between these like bonding groups. So you could have 8-channel capable modems load balancing between multiple 8-channel bonding groups. Because if you're doing 24 downstreams, you might have 3 8-channel bonding groups, embedded. So you could have load balance between those. To activate that, you have to turn on load balancing in general. You have to turn on 3.0 load balance in general. And then you have to turn on 3.0 dynamic downstream to make the utilization start processing. So there are like 2 or 3 commands there. The other thing I point out is,
so I have that up on the slide.
I've seen where, and this is the default setting.
Is that what? So we have multiple commands that I'm showing on a slide.
Was that?
I have that up on a slide right now. We're showing the multiple commands that you're talking about for cable load balance DOCSIS 3.0 enable, cable load balance DOCSIS 3.0 enable dynamic downstream, and load interval 300. Is this what you're talking about?
The other one that's not, the one that's not on there, it's on the next slide. It would be cable load balance DOCSIS enable. So there's a cable load balance DOCSIS enable, a cable load balance DOCSIS 3.0 enable, and then there's a cable load balance DOCSIS 3.0 enable dynamic downstream.
Okay, so this is the one where you're saying.
So yeah, just leave it on that slide for now. And
you said stay here for now?
You just broke up. I just lost you.
Yeah, stay here for now.
Yeah. Stay on that slide for now. I can cover the last bullet point of the last slide, and that was load interval, because it's actually at the bottom of this slide as well. The default load interval, load dash interval, is on is at 300 seconds. That's the default. 300 seconds is 5 minutes. What that does is that dictates our rolling time window for our utilization gathering for all of our load balance calculations. Well, a 5-minute window is a little bit coarse, meaning it's not very fine granularity as far as looking at the utilization as smaller, finer granularity time slot. So I'd rather have a smaller rolling window so I can see the utilization in that smaller window. Because if you move a modem from one interface to another and it takes 5 minutes to update the utilization, well, now load balance is like, oh, I need to move another modem and another modem and another modem. 5 minutes later, everything catches up and it's like, oh, now I need to move modems back. So by updating my utilization reporting more frequently, I get a better indication of that instant in time. It's not really that instant in time, but it's a 30-second rolling window. It's more realistic. Our load interval, by the way, can't be any lower than 30, so that's the lowest setting. So that should be configured everywhere on all cable interfaces, all integrated interfaces, all modular interfaces, all wideband interfaces. And I'm recommending that everywhere. If you look at this slide we have up right now for the people on the podcast, download the slides. I list some recommendations for load balancing, some best practices. This is trying to achieve my 3 goals I mentioned: limited number of moves, don't move too often, keep the interfaces from being congested, and do utilization load balance. So we have a watermark, and these are global commands I'm pointing to on the slide. One of the ones here is called load balance method utilization min threshold. The default's only 25%. I've been recommending a higher percentage of 60. What that means is, if any interface is below, if all the interfaces are below 60, I don't care what the delta is between the interfaces, because none of the interfaces are really congested. But once one of the interfaces gets above 60, like a watermark, then I look at the delta between 2 interfaces, and if it's more than 15%, which I have configured in the load balance group lower in the slide, then I'm going to start moving modems from the high congested to the lower congested. Does that make sense, Brady?
Yep, absolutely. Yeah, because sometimes I will see, like with utilization, you see cable modems going all over the place, being moved way too frequently.
And we saw this as well, where even if they were congested and load balance was working properly, a modem would be moved, and we were very unbiased about who we picked. We pick a SID, move the modem, but what if that modem had no real traffic? If it had no real traffic, it wouldn't contribute to the load balance. So then you'd have to move another modem and another modem. Like, what if you have set-top boxes? Do you exclude all the set-top boxes from load balance? Well, you could, or you could just do this rule I set up here, where I said any modem that has less than 100 kilobits per second upstream and or less than 500 kilobits per second downstream, don't let them load balance. So I put these 2 rules into a policy. So policy 1 is consisting of 2 rules, an upstream and downstream rule, and then I add that policy to my load balance group. So this is telling the CMTS to don't bother with modems with low speed. And it has nothing to do with what's configured in the CM file. It's what speed is that modem doing right now. So this eliminates excessive movement, because why would I move a modem with low throughput?
So this does downstream load balancing. This is also doing upstream load balancing? Correct.
And according to the DOCSIS spec, a DOCSIS load balance group must contain an upstream and downstream in the load balance group, or it won't work. So you can't technically make a load balance group with just downstream. You could make a downstream load balance group with 1 upstream, so there's no real upstream load balance, but it must contain an upstream in the load balance group.
Okay. Anything else you want to cover here?
Right. So here I actually put in a set of downstream RF channels, maybe a set of upstream channels. I changed the method from modem count to utilization. I said whenever 2 interfaces are more than 15% difference apart, then I'm going to load balance. That's the 15. The policy pure downstream load was a command we recommend, so that when we're looking at downstream load balance, we only look at the downstream load. We don't rely on the upstream load to dictate. So that policy doesn't negate upstream load balance. That policy just says, look at the pure downstream load for downstream load balance. And NIT technique list 4 says, let a modem move between interfaces and get layer 3 connectivity up really as fast as you can.
Is there any
So
time,
don't worry about doing.
Yeah, is there any time that you would not use a NIT tech list 4? Say use a NIT tech list 3 or a NIT tech list 2?
Yeah, I mean, it's a NIT tech list 4 is very aggressive. And if you have modems that, let me give you an example. let's say your downstream frequencies are not contiguous and you put some at the low end of your spectrum and some at the high end of the spectrum. And if a modem moves from, say, 111 megahertz up to 753 megahertz, the levels inherently are going to be a lot different in a real cable plant, the downstream levels. With more than 4 or 5, 6 dB difference, I've seen modems go offline. Whereas, and it still might go offline even with the other techniques. So I always tell people, put your RF frequencies contiguous. Don't do this. Try to do this if you can, because load balance sometimes doesn't like that movement's so far apart. But we've seen where modems move to different downstreams and get different time offsets. And Technique 4 is not very forgiving when the time offsets change by more than about 10 time offset ticks, especially when doing 6.4 megahertz upstream channel width. So with that said, I've seen cases where I do low balance, Technique 4, I try it, modems go offline, then I'm like, all right, let's go to Technique 3 and see if they work better. And maybe it's actually a specific type of modem. So I might be able to say this MAC address or this OUI of all these modems, you'll do Technique 3, whereas all the other modems will do Technique 4. So Technique 3 is much safer. It'll make sure that the modem will do a station maintenance pretty quickly. It doesn't go offline, it stays online, but you'll lose layer 3 connectivity, maybe for 4 or 5 pings, maybe 4 or 5 seconds.
So losing
modem stays online.
connectivity, would that be noticeable to, say, someone who's on a phone call? Would that call be dropped?
I mean, that's a good question, because by default, when a modem has a voice call, we don't load balance it anyway. So that's a good thing. Now, if that customer was doing Vonage, that's a whole new story, right? Because it's best effort. It's not doing UGS. So a modem doing Vonage call or Skype, it could load balance because it's not being excluded, because we as a CMTS have no idea. It's still doing best effort flows. We could move it, and then, it could lose, 4 or 5 seconds or freeze up for 4 or 5 seconds.
How about if they're doing...
But if it was Technique 4...
they're like, now we have Verizon that's doing Wi-Fi calls.
Yeah, good point. I mean, and it's probably still a best ever call, right?
Right.
It's probably like Vonage. Not setting up a DQoS, dynamic quality of service. It's not doing UGS. It's
the same as Vonage. I mean, it's over the top calls.
Yeah. I always said that the more Vonage, Skype, and now maybe Wi-Fi calls that we have in our plant, the worse it gets for them, for each other. Not necessarily for a wired line or other data traffic. Because what happens in a cable modem CMTS is modem makes the request for upstream bandwidth, and on a downstream map, it'll say, all right, here's your time to send. Now, that bandwidth request could have a contention, collision, and then it will back off and try again. But once the traffic starts flowing for data, embedded in that traffic will put another request. We call that a piggyback. So once the data starts going, the subsequent requests after the first one will never have contention because it's guaranteed time. But when you look at Vonage and Skype, there's these every 20 milliseconds, a little voice packet, and it sounds pretty fast, but it's actually pretty far apart when you look at microseconds. 20 milliseconds, every 20 milliseconds, we end up doing a contention request for every one of those 20 millisecond packets. So you end up with a lot of contention requests that have the probability of colliding with other people's contention requests. So a Vonage customer, more Vonage will probably interfere with more Vonage. Whereas more Vonage doesn't really interfere with other people's data, because once data starts doing piggybacking, then it just keeps flowing through.
Right.
Understand?
Yep, absolutely.
So, so up here, this was some of the settings I was recommending for load balance, and people can look at the slides and go from there.
Yep, absolutely. So we got some more questions. Are you ready for them?
Yeah, keep it going.
So
next one, long day. I need a big jug. This is my coffee cup. Where's Ron Hernick at?
That is a big jug. Was that a Chris's gift? All right. This next one comes in and says, we are having problems with modems that go offline and then drop into DOCSIS 2.0 mode, just one downstream channel, when one of our 8 downstream channels becomes impaired. Is there a way that we can have a modem stay online with sort of like in a downstream partial mode, like it does in the upstream. Thanks, Rick. So, you know, we're dealing with, we have a bonded downstreams. One downstream becomes impaired. Really should stay online in a bonded mode, right?
Yep. So let's cover that from my perspective, Cisco CMTS. We have a global command to turn on the processing of CM status messages from the cable modem. If we don't turn on that command, anything being reported from the cable modem, as far as, hey, my QAM is unlocked, my downstream FEC is unlocked, MAC domain descriptor is bad, all these little CM status messages, according to the spec, that come from the CMT or cable modem, the CMTS won't process it unless you have this global command. So if you put up the slide, I think we have another slide on this one, right?
Yes.
On the partial mode stuff. If I put in this global command, we will start processing these CM status messages, and then we'll start marking modems that report these problems as P online. Now, if you don't have this command on the CMTS, the modems could say P online, and then they'll directly go offline. Then they'll register W online, P online, offline. So you can see modems just cycling through registration because you didn't turn on the capability to process the CM status messages and place the modems P online properly and keep them there. Because once the modems get P online, I can do show cable modem, pipe include P online. I can see all the modems. I can do show cable modem partial service. I can see which modems are bad and which frequencies the modems are reporting are bad. So I can start tracking and troubleshooting some of my issues. Now, so we're showing here a global command, cable RF change trigger %50, count 10 secondary. That command is saying if I have more than 10 modems reporting the same RF problems and greater than 50% of all my modems in that service group reporting the same problem, I'm going to put all the modems in that service group in a subset bonding group. If I don't reach those thresholds, modems will still report P online. Those modems that report P online will not do a subset bonding group. They'll actually, say it's reporting 8x4, 8 downstream channel bonding. You could do a show cable modem wideband channel or show cable modem partial mode, and it might say 7x4, but when you look at that modem's MAC address, like show cable modem MAC address, quality of service, or service flow verbose, that modem's best effort, downstream service flow, could be using the integrated or modular interface, which indicates it's using a single downstream. The forwarding interface of your traffic should say wideband interface. And it's saying integrated, that means that modem's traffic is actually using a single downstream. So you could have a modem that says P online. You think it's doing 7 channel because it was supposed to do 8, but it's partial mode. It's actually doing single channel. Now, the good thing about P online is if the modem reports the QAM is better again, it can go from P online back to W online automatically and go back to the full 8 channel.
Does that have?
If you really want to,
how does it
say again?
Check that the downstream is good again?
So that's a CM status message. So the cable modem must report the CM status message and say, hey, my QAM is now locked. So we have some inherent issues with that as well, which I'll kind of cover, I think, in the next slide. But if you really want to have modems use a small bonding group, like 6 channel, 7 channel, 5 channel, then we have another feature called resilient bonding groups, where you create an empty bonding group and the CMTS will automatically populate that empty bonding group with the downstreams that the modem says are good. So here's a case where the CMTS create a bonding group specifically for 1 modem or 10 modems, whatever modems are having an issue, like the same issue. Let's say you have LTE ingress and it's affecting 5 modems downstream of that ingress point. Those 5 modems will all report the same issue, so those 5 modems will all get put into the same resilient bonding group. Good?
So when these are fairly new commands, aren't they? What iOS version did this stuff become available? Do you know?
For the 10K, it might have been all the way like SCH.
Okay.
Like SCH code. For the CBR8, it's been there the whole time. Yeah.
Sure.
It's just that a lot of people don't either know about it or haven't implemented it.
Yeah, this is really nice stuff. Really nice.
And I would say once you get to 24,000, yeah. And if you get to the next slide, I mentioned a recommendation on, you just asked the question of how does the CMTS know the cable modem is good again? Well, the cable modem has to report, hey, I'm good. Actually, maybe we skipped that slide.
Yeah, I think we did.
Maybe you took it out. I had a recommendation for the, what was it? Processing the CM status message. By default, we look at increments of 20 milliseconds, and the default is 50 increments of 20 milliseconds. It's something weird like that. When we do all the math, it says 2 reports. The command by default is saying, when the cable modem has an issue, send me 2 reports total, 1 second apart. And if the modem has a problem on the upstream and it doesn't get to the CMTS is like, all right, I don't see anything, and the modem can stay P online forever. Because the cable modem won't continue sending, because you set up a command to tell the cable modem to only send 2 reports for every instance. So I have a recommendation to double the 50 to 100 and take the 2 reports to 10. That way the cable modem will do every 2 seconds, but 10 complete tries. That way I have a better opportunity of maybe getting that CM status message. Does that make sense?
Yeah, so this is to help the modem come back online and off of a partial mode more rapidly.
So not back online, but help to get the information from the modem that it's good again.
Right. So
I'm seeing a lot of cases where the modem is good again, but it's not telling the CMTS. The CMTS is like, oh, well, I don't know what to do, so I'm just going to keep EP online.
Okay. Makes sense. So, okay.
The next slide, I think, is a different topic for the model.
Yeah, so the next slide that we had here was going over, you and I both have done a lot of work on cable modulation profiles, and I think we just wanted to kind of cover that information a little bit, sort of what our best recommendation is for optimal cable modulation profiles.
Yeah, the end of this is dictated by the Broadcom or Intel or whoever makes the upstream chipset, because their chipset is the one decoding everything. So a lot of these settings should be basically the same for ARRIS and Cisco. What we've learned in the past is if you want to make the CMTS self-healing, where the upstream can change its modulation on the fly, I always recommend keep it simple, stupid. So I say, you know what, we want to do 64 QAM as my fastest speed, but don't drop the 32 QAM. Drop all the way to 16, and then if that's bad, drop the QPSK. Let's not make this more difficult than it needs to be. If you drop from 64 QAM to 32 QAM, you're only gaining 1 or 2 dB in robustness. So if you're a CNR and MER on the upstream channel, it's just fluctuating 3 dB, you could have a modulation just hopping back and forth and back and forth. I'm going to change modulation. I want to change to something that's going to give me 5 to 7 dB more robustness. I want to be safe. And I want to do it like not too often and still not drop too much speed. But this is the safest. I found this is the safest way for me to keep a stable upstream. I do the 64 QAM with 16 QAM in the mod profile for the maintenance of the modem. And then if that's bad, my bad MER, bad uncorrectable effect, I'll drop to a pure 16 QAM profile. If that's bad, I'll drop down to a pure QPSK profile. And then customers will come back and say, well, John, if I drop the QPSK, I'm going to drop my voice calls, I'm going to drop my traffic. And I would say, well, isn't it better to still have some traffic than trying to run 64 QAM and everything's dropping? So, I mean, if dynamic modulation is changing on the fly, there's a reason for it, and you need to figure out why. Your upstream is noisy. I mean, I'm not saying that you shouldn't be tracking it. Had customers come back and say, well, John, I don't want to do dynamic modulation because then my RF techs won't go out and fix the problems. I'm like, that's an internal problem. That's documentation. That's tracking. That's alarms. That's flags. That's SNMP. That's you guys, getting on your employees to see that the modulation has changed. You get a flag. The NOC sees it, and then you tell your RF techs, this modulation has changed. Let me see path track. Let me see the spectrum analyzer. Let me use PNM. Let me see why this modulation has changed. Show cable hop history. While the MERs drop, this is why. and let's figure out why. And let's figure out what we need to do.
So one thing that
maybe I turn off dynamic modulation.
Yeah, one thing that I would ask you about here on the modulation profiles that are all 16 QAM and all 64 QAM for the AUGS flow, that's where your voice traffic goes. A lot of times I like to keep those one order modulation below what the data traffic's flowing, the A short and the A long. What are your thoughts on that?
So we used to do that as well, especially when people were hesitant or apprehensive about doing 64 QAM. Like they were doing 16 QAM forever. They double it to 6.4 channel width. They drop 3 to 5 dB on the MER. They turn on pre-EQ. The MER comes back up, but they're still hesitant on the 64 QAM. So there's like, voice traffic is more critical. So let's make sure the AUGS burst is still 16 QAM. And I've had customers do that for a long time. And then they're like, well, and there's not a whole lot of calls, but if they do see some of their call traffic going up, they might say, you know what, it would be better if we went back to 64 QAM because our plan is pretty clean. We're not having uncorrectable effect on our data. So maybe we can go to 64 QAM on the AUGS now that I feel safe and I feel a little bit more secure with 64 QAM. And it'll take less mini slots now and I can get more voice calls. And whether or not you get more voice calls might not be the issue, but each voice call is taking up more mini slots on that wire when it's 16 QAM. So, you could say an ounce of prevention with a pound of cure. You could say, yeah, I'll run lower modulation because it's safer. But then the trade-off is it's eating up more mini slots.
Right.
So it's kind of like
possible you keep the modulation as high as the data modulation. If you have problems, then you could always drop the voice down.
Yeah. Exactly.
Okay. All right. Well, we're getting pretty close to the top of the hour here, John. You did have some slides on DOCSIS 3.1 CMTS optimization. Can we cover those?
Yeah. I don't think we had a lot in there. I think we just had a couple bullet points.
Slides. Let me cue them up and let's present those up. And as I think that's some
3.1
relevant information.
Yeah, I'd say 3.1 downstream is becoming more prevalent now. Customers trying to offer 500 megabit per second, 1 gigabit per second on the downstream. So 3.1 is coming to front. Upstream, no one's really doing anything with 3.1 upstream. One, because we really don't have any spectrum. Everyone's still doing 5 to 42 megahertz. Now, on the D3.1 downstream front, a couple of bullet points I had up here. One was talking about the downstream guard band. Depending on the settings of say I'm doing a 192 megahertz wide OFDM DOCSIS 3.1 block, it could still be a channel, call it a channel. Inside that channel, every 50 kilohertz or 25 kilohertz sub-carriers, let's say we're doing 50 kilohertz, some people call that 4K FFT. Now 4K just meant 4,096, right? 4,096 sub-carriers inside there. Out of that 192, it's really based on a 204.8 channel, and then there's some null that you don't even know about, and then 192. And in the 192, you still have guard band inside there. Now, depending on the cyclic prefix and some other settings, that could be 2 megahertz of guard band. So there are some settings to try to make that guard band smaller, so you have actual more usable bandwidth within the 192. So there could be some recommendations on the guard band, some settings to get more speed. That could also be dictated by, do you have other channels contiguous to the OFDM block? Do you have a video channel right here? Do you have a DOCSIS 3.0 right here? Do you have another OFDM block right beside it? So that could, interfere. Is it near the end of the roll-off? You're a 750 megahertz plant and it actually rolls off. Maybe I need more guard band, or maybe I need less guard band because it just rolls off anyway. So there's some things to think about where my placement is. Mixed mod profiles. We do allow the OFDM block to have different modulation in those subcarriers, like anywhere in that group. You could make a mixed profile to be optimum for your RF plant. You could have a mixed profile that's optimum for just one leg of a fiber node, and all those modems get assigned to that mixed mod profile. And modems in the same service group with a different leg of a fiber node might be doing 4K QAM, meaning 4,000 different modulation or higher modulation scheme because they have good MER readings and they don't have suck outs and roll off and stuff like that. The third bullet point talks about the graceful profile management, quarter dB MER, and percent exclude. What we found, and we did that Google Hangout with you and Jason Miller and Jeff Riddell a couple of months back, where we talked about, we found that if I have ingress under my OFDM block, that and time interleaving that DOCSIS 3.1 includes and incorporates makes it pretty robust to like steady state noise. And what we found was that even if my carrier noise in a section of that block was like 20 dB, the 4K QAM was still working, which sounded impossible, implausible. But because of this interleaving on frequency and time, it turned out we were getting the full spectrum. So all the speed that I thought I was supposed to get, I was actually getting, even under the subcarriers that only had a 20 dB MER.
Yeah,
so it's kind of interesting that
we covered that I think on the last podcast. That was really counterintuitive.
Yeah, like,
really great information, you guys.
Yeah, like 2 months ago. It was probably, was it December?
Yeah,
November.
November.
Yeah.
We skipped December.
So with that, some of that information, I said, the default setting Cisco has right now for exclude percent is only 2%. So out of the 1, 2, we say look at the MER of all the subcarriers, and if they go below a certain number, a threshold, we're going to change the profile dynamically. 2%. So if I had a little suck out or noise and it was 2% of my subcarriers and the MER was 10, that wouldn't dictate my entire profile changing. But with this new testing of interleaving, frequency time interleaving, I almost feel like that 2% might be able to be increased to 10%. To say, you know what, out of 192 megahertz, 10%, 19 megahertz that have low MER, don't worry about it, because I think it's robust enough to take care of itself. So I almost feel like more field experience will give us better best practices for that percentage exclude, because I don't want the profile changing too quickly, because you would just be going from, say, 4K QAM to 2K QAM to 1K QAM to 256 QAM, and maybe you really didn't need to. And our internal tables for those thresholds are really conservative. They're based on a DOCSIS 3.1 spec, which already adds 6 dB of headroom. So we came up with a quarter dB MER correction factor. So if you feel like our internal tables are too conservative, you can say, all right, I'm going to do 12 quarter dB correction factor. Well, 12 quarters is 3 dB. So instead of 4K QAM breaking at 43, the 4K QAM will break at a 40 dB MER because you gave yourself 3 dB of correction factor. The other bullet point I point out, and Jason Miller pointed out, was we found that with DOCSIS 3.1, you end up with a lot of correctable FEC, which is not a bad thing because it's corrected, but just because of how it works with the interleaving, the low density parity check, how things work, you might end up noticing a lot of correctable FEC, and you might start questioning your RF plant when it really, there's nothing to question. So if you get uncorrectable FEC, that's a different story. But as correctable FEC, don't worry about it.
Right.
And then I have another at the very bottom about the clocking that we use. I found that DOCSIS 3.1 modems were showing super high time offsets. Then we realized it's because the OFDM is based on a 204.8 megahertz clock, whereas DOCSIS 3.0.2.0 is based on a 10.24 megahertz clock. So it's a difference of a 20 factor. So you might see a time offset of a 3.1 modem that says 20,000 versus 1,000 time offset for a 3.0 modem or something like that.
So
right?
the timing accuracy of 3.1 modem still is supposed to be much better than any previous versions of DOCSIS, than DOCSIS 3.0, 2.0, etc. Correct? So when you're saying you're seeing a time offset, the modem's still very accurate.
Yeah. So you might be confused when you say show kill modem, and a 3.1 modem has a super high time offset. And normally we used to think a super high time offset meant it was really far away. where in this case it's a 3-1 modem. So if you take its time offset, divide by 20, that would be the equivalent DOCSIS 3.0, DOCSIS 2.0 time offset, and maybe that number would make more sense to the distance you have for your fiber.
Right. So
A lot
any
of times I
chance
can
with
look at the time offsets and I can almost guess. What's that?
Yeah. Any chance with DOCSIS 3.1 we can use that time offset to actually calculate the distance of the modem from where the CMTS is like we've tried to do previously with DOCSIS 3.0 modems or 2.0 modems?
I think we're still in the same boat as we were 3.0 and 2.0, because we don't know what the slot number is in the modem itself. I mean, we could guesstimate how far, but because of the star architecture of HFC, is it this far or this far or this far? You couldn't really, I don't know. We should just make 3.1 modems with GPS in it, right? Or, long.
Yeah. Just a little bit more cost. That would be a great thing to have.
Was that one of our last questions on there or no? I know we're at the top of the hour.
Well, we have more questions. We're just going to have to save them for next time. Or like you said, we do this at SCTE Expo. We've somehow miraculously talked for 57 minutes. And with that said, I'm going to go ahead and wrap up this podcast and we'll call it a day. So, John, thanks for your time. And we'll go ahead and sign off.
All right. Thank you.
All right, John. Take care to everyone. If you'd like to hang out, subscribe, keep listening, and catch us on the next podcast. So long, everyone, and have a great weekend.